So let us discuss the height of collimation method one problem example. Here you have some stations. I will explain you about these stations. See, this is the first station BM of A. BM of A means benchmark. The station name is A and this is the benchmark. Generally, as I explained you previously, the benchmark is a known elevation. From here we'll see how the survey has been taken place. So the setup one means the instrument has been set up here at setup one place. Once the instrument has been set up, what is the first thing we have to do? As we have to take the reading, the staff reading on the known elevation. First, once you set up the instrument, you have to hold the staff on the known point. Here benchmark means you know this RL, you know this reduced level, so the staff has to be held at A. So once the instrument has been set up and the staff has been held at A, so sight towards A from the instrument. That has been done here from setup 1. The staff reading has been taken on benchmark A. So then next, just use logic. We have some curve and CP1. So probably what will be the next point? CP1 means change point, curve can be the intermediate point. Let's see what the next reading was. Okay, this is not related to this then. So from the setup one, they have seen this point which is known as CP1. So this see here from the setup one, if you have seen to benchmark at A, the known elevation, the reading taken at benchmark A has to be written as backside as CP1. I explained you in the another video. CP1 means when you are going to change the equipment, the lost staff reading is known as CP1. The staff reading at the CP1 becomes foresight. Next, see, the instrument has been shifted to setup 2. The instrument has been shifted to setup 2. Now see what after setting the instrument, after setting the new instrument station, as I told you, you need to check back again to the change point 1. Now you know the reduced level of change point 1. So from the new instrument station setup 2, CP1 will be the known elevation. Okay, so once you set up the instrument here, you need to see back to CP1. As I explained you on the board, if you check back again to the known same point which we have taken from the setup 1, from here setup 1 to CP1 it becomes foresight. From setup 2 to CP1 it becomes backside. So from setup 2 we have seen CP1. Again from setup 2 we have seen curve. And setup 2 again we have seen post, and setup 2 we have seen CP2. So see this, from setup 2 the first point we have seen CP1 is backside and the last point is CP2 is foresight. So CP2 means again after this the instrument has to be changed. So before you change the instrument, the lost staff reading is known as foresight. So from this setup 2, CP1 becomes backside and CP2 becomes foresight, and the curve and post becomes intermediate sights. Now the instrument has been set up at 3. So once you set up the instrument, immediately you have to check back to CP2, which can be written as backside, and curve, which is intermediate sight. Next CP3. So CP3 means again the instrument is changed after this point. So from setup 3 the final staff reading is CP3, so you have to take it as foresight. Now the final one, the setup 4, the instrument has been set up at 4. So immediately once you set up the equipment, you have to check back to CP3. You have to check back to CP3. So that is backside. The immediate one is the close of the survey. From setup 4 again you have seen benchmark. So the end point for any surveying or any instrument station has to be written as foresight. So this is the basic example for survey. This one you can observe again once again what happened here. See, first we have this something the points like this: A, CP1, curve, A CP1 curb, post CP2 curb, CP3. So from benchmark, you need to start the survey near to the benchmark. So the instrument has been set up here. Once the instrument set up here, you have to check onto the benchmark, that is backside. Next CP1. So whenever the reading has been taken on the CP1, that is foresight. So after this, you need to change. You are going to change the equipment. It means that CP1 means instrument is going to be changed. So now the instrument is set up at 2. Now after setting up, the immediately you have to check. After immediately you have to check CP1, which has to be which will become backside. Then curb intermediate side, post intermediate side, then CP2. It means that after CP2 you are going to change the equipment. After setup 3, immediately side towards CP2, write it as backside, then curb intermediate side, then CP3 foresight, because this is the last staff reading from setup 3. Now instrument has been set up at 4. Right reading take side to CP3, which is written as foresight, backside, and the last point taken in the survey is taken as foresight. Here you have a table so that you can understand how to write and what to write. Here back means BS, intermediate side, foresight, and these are the points. So from the setup 1, we have gone, we cited 2 points, BMA and CP1. So here we'll see where the reading should be written. So one from the setup 1, when cited to benchmark A, where the reading has to be written backside. See, the staff reading here is written at the backside. You can observe here the 1.32 is the staff reading, which has to be written at backside. Immediately after setup, from setup 1, we looked at CP1. CP1 means the instrument is going to be changed. So as I told you, the staff reading taken on the change point has to be written on foresight. Okay, setup 1 has been completed. Now the instrument has been changed to setup 2. From setup 2, it was cited to curb, post, CP2 as well as CP1. So when you change the setup 2, what the first step you have to do, you have to look back to the CP1. Where is the CP1? See, here you have CP1. The staff reading has to be written in the CP1 backside. The CP1 is a point where the foresight and backside both will be there. So from the setup 2, when you have taken the CP1, the 2.56 is the backside. From setup to CP1, we have taken the reading that comes under backside. Now the readings taken, any reading taken up to center CP2, the change point 2, will be considered as intermediate side. Now see, from setup 2, the reading has been taken at curb. So the curb, the reading is written at intermediate side. From setup to post, the reading is at intermediate side. From setup to finally CP2. So after this, the instrument is going to be changed. So the reading will be written at foresight. So now change the instrument to setup 3. Once you change the instrument to setup 3, you need to cite to CP2. So once you cited to CP2, the reading has to be written at backside. Okay, CP2. From setup 3, curb, intermediate side. From setup 3, CP3. The final reading again it becomes foresight. Now change the equipment again. Setup 4. Once you set up 4, then need to look back to CP3, which is backside. Look back to CP3 means again it's backside. So now it's backside. You can see the backside reading here. And final, it ended at benchmark A. Again it is foresight. So this is the way how to write the readings, where at backside, intermediate side and at foresight. So this is the table, how to write the values and all. The tables have already taken the backside values, the intermediate side value. From the previous slide you can observe the backside values are written like this, the intermediate side values are written like this, the foresight values are written like this. This is the general table which you should remember for the height of collimation method. You can see back side, intermediate side, foresight. The HCP is known as height of plane collimation method. You can height of plane collimation. See the formula here, RL plus backside. Okay, it is not HCP. To maintain the standard, HPC has been changed here. So this is HPC, height of plane collimation. See what is the formula? Height of plane collimation is equal to RL plus backside. RL means RL of benchmark A plus backside. So the 50 is given. It is the known elevation of benchmark. So the RL at A, the benchmark is 50. Now you need to calculate the height of plane collimation. So you can you might be having some doubt where you can calculate the height of plane collimation. Generally the basic concept is wherever you have backside, you need to calculate the height of plane collimation there. So here you know the RL, you know backside, you need to calculate height of plane collimation. Height of plane collimation is equal to RL plus backside. So 50 plus 1.32 gives 51.32. So you have calculated the height of plane collimation here. So with this help, next you need to calculate the height of plane collimation and RLs of point. So once you know the A, the next point is CP1. So you need to calculate the RL of CP1. Once you want to know the RL of a point, the formula is height of plane collimation. Either it might be foresight, either it may be intermediate side. So to find out the RL, the formula is height of plane collimation minus foresight or intermediate side. You can see this from here as I explained you. If you want to calculate RL of another point, the formula is height of plane collimation minus staff reading. So here staff reading is foresight and intermediate side. So see here, you need to calculate RL of CP. You know height of plane collimation, you know foresight. So height of plane collimation minus foresight will give you the value RL of CP1. See. Okay students, continuation to the presentation. This is the problem we need to solve, and I explained you how to write backside, intermediate side and foresight according to the diagram. So the first, we know the formula HPC, height of plane collimation, is equal to RL plus backside. So this is the first basic formula, height of plane collimation is equal to RL plus backside. You can see you have RL here, you have backside here, you need to calculate the height of plane collimation. So you can write points here. I need to write the points. So that the first point is BMA and second is CP1 and then curb post CP2, curb CP3 and ends at benchmark A again. So you can see RL plus backside, 50 plus 1.32 gives you the height of plane collimation 51.32. So once you calculated the height of plane collimation, you need to calculate the RLs. The simple logic is that wherever you have backside, you will get height of plane collimation over there, and all points we have to calculate the RLs. The next step is to calculate the RL of CP1. So now how you calculate the RL of CP1? See, the formula is to calculate the RL, HPC minus IS, HPC minus FS, HPC minus intermediate side, HPC minus foresight, whatever it is. So for here you have foresight. So to calculate the RL here, you need to do this HPC minus foresight, 51.32 minus 3.98. The value is 47.34. 47.34. So again see, once you calculated the RL, you have backside here, it means the instrument is changed. So you need to calculate the HPC here. To calculate HPC again, RL plus backside. So 47.34 plus 2.56, the value is 49.90. So from here you got the height of plane collimation. So to calculate the next 3 RLs, you require this intermediate site and foresight. So from HPC minus intermediate site, HPC minus intermediate site and HPC minus foresight. I am just copying the values. So now you need to calculate the RL. RL at curb 48.65, RL at post 46.25, RL at CP2 49.23. So once the foresight is over, again you need to calculate the height of plane collimation. So how you calculate the height of plane collimation? The same thing, RL plus benchmark. So 49.23 plus 3.49, the value is 52.72. So once you got the height of plane collimation, to calculate the RL of curb, again do HPC minus intermediate site, HPC minus foresight. So 52.72 minus 2.58 gives you 50.14. So RL of CP3 52.72 minus 1.54, it's 51.18. So again you need to calculate the height of plane collimation. 51.18 minus, RL means 51.18 plus backside 2.64, that is 53.82. So once you know the height of plane collimation, then height of plane collimation minus foresight. So 53.82 minus 3.83, it is 49.99. So this is the final benchmark at A. You can see when you started the RL at benchmark A, it was 50. So once you ended, it is 49.99. So there is an error. So when you need to calculate the error, you have a formula that sigma Bs minus sigma Fs is equal to lost RL minus first RL. So you need to calculate the whole sigma. So calculate sigma Bs, sigma Is, sigma Fs. So consider this lost RL and consider this first RL. So I will show it to you again in the presentation how to calculate the formula. The basic formula is sigma Bs minus sigma Fs is equal to lost RL minus first RL.